Greetings, ladies and gentlemen, and everything in between. So this is just released a day or two ago. Garry Nolan's um, conclusions, or part of the way conclusions on these UAP materials that he's had for a while. If you haven't heard of them, look it up, or else hold on. I'm going to cover that a little bit more in depth another time. I'm not going to watch this whole thing, but I thought it'd be cool to watch it with some other people. So here we go. Unidentified aerial phenomenon. November 23rd, the Soul Foundation held at Stanford University the first of its kind symposium on UAPs. These are the folks that are
So again, I want to thank everybody for coming. Really appreciate it. And I forgot this morning to mention Dave Grush. Dave can't be here because of travel that he's doing right now. But I want to remind everybody that he was a partner in setting this up. And we're proud to be associated with him, just so everybody knows. And so Dave, if you're listening, so what's inevitable? Inevitably, we're going to come across something out there that is alien. I mean, let's just be serious about it. Or at least life, let's say. But how do we engage it? And how do we begin? And so, you know, I think we start with the problem is everything is made of stardust, right? So how do we approach this? We don't understand the rules, frankly, of how it all goes together. As a biologist, I study the basic gears and principles of what goes on inside of a cell, and then we basically figure out how it works, try to. And so I think of potential UAP materials as something that I can approach with the same methodologies that I have with cancer research. It's straightforward. You have to analyze it, but at what level do you analyze it? So, because we don't understand the rules of how it all goes together. And, if you think about Avi's work with the meteor from 2014, which seems to have a structural integrity that defies.
So he's referring to Avi Loeb, um, another highly accredited scientist that's looking into the topic as well. Real quick before we go too far here, if you don't know who Garry Nolan is, I mean, this guy's top of his field. He's been working at Stanford for quite a while now. Um, you can pause this and read through it if you'd like to. He's a gangster in his field. So it's a huge boon to the UFO community to have this guy on board, right? Look at all these patents. Wow. Damn. Okay, let's get back going here.
At least a good portion of the astrophysics community's desires. And then you think about what Kevin spoke about. Obviously, somebody has an understanding of physics that we don't, but that means that they're putting things together in ways that we don't understand how they're doing it. So let's back up here. So technology, invention, Stanford, and questions. From exobiology to Silicon Valley and biotech. So in the department where I got my Ph.D., there was a gentleman by the name of Joshua Lederberg, and he'd got the Nobel Prize for being the first to show how bacteria have sex. And so he was the chairman of the department. But he was interested in what's out there. And so he,
Okay, so I've seen a couple of the main clips of this video. This, I think, is just going to be about the shoulders of the giants that he's standing on. The folks who created the equipment and the technologies to allow him to do the research he's doing today. So,
materials from a UAP. Well, like I said before, it's you take it apart piece by piece, you try to understand the components, and you try to ask the question, why is this component here next to that component, and what might they be doing with each other? So, but it's not just about that. It was about that there's data out there that something unusual is observed, and the speakers this morning went over this, and the evidence is collected in a crime scene, and I got interested in it because of this. And so, but as it turned out, some of this evidence appeared to come from UAPs. Is it the steering wheel? Is it their version of a television screen? What is it? What did they leave behind, and why did they leave it behind? Is the question. So how do we analyze it? So I mean, I won't go into all of the this whole slide, but I mean, it's really about using the tools we already have, and I happen to have laboratory tools that allow me to look at metals. I'm not a metallurgist, but I play one on TV. But I had the tools, and I had the interest, and I had a good friend by the name of Jacques Vallée, who brought me some of these materials because he said, "Hey, let's look at this." And I should say right up front, Jacques and Hal Puthoff, Eric Davis, Colm Kelleher, all those people, frankly, rescued me from the rabbit hole of ufology.
I'll say it's worth looking up those names and doing some research if you're interested in this topic. Those guys, especially Jacques, has been leading the charge for decades. Several books. He's incredible. It's so amazing to have him teamed up with a scientist of this caliber.
uh, because I was wandering, and they said, "Here's a guy who we might be able to work with him." So it's all about, and also functional analysis. Just knowing what a thing, how it's made, is not the same thing as knowing how it functions. So, but it needs that interdisciplinary team. That what happened in the Department of Genetics. Okay, so how to do science right? So where do we start? That's who I see when I look in the mirror. So where do we start? Let's get this show on the road. That's ChatGPT. I love it. So the first case, and this is the case that we published in basically last year, and it was with Larry Lemke, a postdoc of mine, and well, Jacques, sorry. And so again, it's about the evidence. You can't just take anybody's claim that something is the truth. So this is one of the best and most widely observed at the time of cases. Multiple observers, et cetera. I won't go through them all, it's not necessary. But a hovering object, and then something seems to slough off and drop to the ground. And some people were like, they were literally only within about 500 or so feet from it. So the police, luckily, were called. And here's one of the observers down here in red, another observer, and this is where they ran to. And what did they find? This is one of the actual original photographs. We have them. And it's a big pool of metal that was in the process of cooling. Okay, so how did that get there? So, they went through all of the possible reasons it could get there, from hoaxes through thermite, through a meteoric crash. I mean, who would think this is a meteor? It would have left a hole. Space debris reentry, all of these things were dismissed. So,
Yeah, so I, and probably many of you know about these instances. There's several of them. Decades ago, one was in the 50s. Um, And it's really intriguing. What the hell are they dumping out of their UFOs? I have thought about this a lot, and I kind of was thinking along the lines of discarding some, like, it's a remnants of the fuel, like the leftover portion of what they're using for fuel, possibly. Um, I guess if that was the case, they'd have found some of that while doing these analyses. Um, the only other thing I really can think of is, I mean, could they be dumping this stuff off to kind of give hints to aid in disclosure in a way, to make it more difficult for the government and people to cast shade on these people? It doesn't matter if they're a police officer or not. We've seen it. If they get called crazy, the stuff gets swept under the rug. But physical evidence is different. I mean, even if they couldn't do a proper analysis on this material in the 50s, we're doing it now. But at least it was something. Molten metal on the ground being dumped out of a UFO. I mean, it's just amazing.
So, but of course, it's just something sitting in the literature. Um, and this is where we published that paper. And just, so there's always this question I get about reputational damage. So Suzun Jiang is on this paper. He's now a professor, assistant professor at Harvard and over in the medical school. Didn't hurt him. They fought for him. There's Suzun right there. So the first technology that we brought to this.
Last interruption for a bit. What he's getting at there, I think, didn't hurt him, is the fear that runs through the scientific community to speak up or to step into the fold, right? Like him, and at least at least take a look at some of the evidence, do some tests, not just blow it off. Neil deGrasse Tyson is a huge issue with these guys right now. I plan to do a little short video on that, but they're really angry and disgusted with him. He really pokes fun at these people and has even been pretty critical of our Navy pilots, like really roasted them. And he's starting to look like a shill because he won't even have a conversation with them about the materials or about any of the evidence they have. Every interview, he just blows it up and is like, how ridiculous it is if they can't show him a dead alien body. Anyway, next video.
This is one of the ones that was developed in my lab, actually by Mike Angelo, who's here. Michelangelo. Reincarnation. And nobody is. I mean, when he showed up in my lab, I thought he was crazy because he was all excited about something that he thought we could do. And I thought, you know what? It sounds possible. So let's do it. So we took these materials. We had a big chunk of this material. We took 5 different pieces of it, very small pieces, because these things require tiny amounts of material to study. Because you don't want to look at just one thing if you can. As long as if it's relatively inexpensive, you want to look at multiple places. You want to, as we say when we're looking at the tumor immune interface, we want to sample the ecosystem. So took multiple things just to make sure. So, the first thing, as you all know, we went and looked at isotope ratios. We didn't find anything. They looked absolutely normal. But I noticed something in these signatures, and those are the metals that came out, is that the ratios of the elements were different from one to the other, right? So that means it was not homogeneous. Somebody didn't put it in a blender and make a uniform distribution. I mean, if you're making a material for something and it is different in different places, then you're going to have structural issues where one part might be less or more bendy than another or more likely to crack, et cetera. So that was interesting. That means when this stuff, when it was dumped there, however it was, but we'll take the word of the, because it's fun, right? I mean, speculation ends up being a headline, Stanford professor says, Harvard professor says. No, it's speculation. It's just a game to play in your mind. So you have these different ratios, which means that before it was dumped out, it was incompletely mixed. So what does that mean? How and why would you do that? I mean, were you offloading something that was problematic? We all heard the stories about how these things might wobble, and then something happens, another one shows up, and they fix it, and then they go off merrily ever after. So, and these were just the ratios.
Yeah, I've seen videos in the past of these UFOs dropping this metal into the ocean, which is super cool, right? Because it's like lava hitting water, steaming and just bubbling. It's so intense. I wish I knew what the hell they were doing.
Ratios. And there they are. So they're not slightly different, they're completely different, right? So everywhere you look, I've explained it before, like you have chocolate and vanilla ice cream along with strawberry. You let it melt, you give it a couple of twirls, and wherever you look, there's going to be a different ratio. So what can we conclude from this? It's clearly the result of an industrial process. It's not the machine. Maybe it's exhaust. Maybe, who knows? We don't know. It had incomplete mixing of components. That's a conclusion, right? I always talk about data and conclusions, that it's about the data, not the conclusion. Get another scientist to agree with the data, that the data is real, and now you get to ask them why. The onus is not entirely on you, right? There was no signs of any technology and no exotic isotope ratios. Okay, so, can we look deeper? I mean, that's a pretty high, that's from a structural analysis point of view, if I'm talking about atomic, machines, this is like the 30,000 foot, but it's what was available at the time. And it wasn't really something that I had thought about much, but then, can we do this? Can we see smaller? And why would we want to do that? Well, like with the immune system in cancer cells, the proximity of where one is relative to another actually predicts the outcome of the cancer and whether the therapy will work or not. So we went to this instrument. This is atomic probe tomography. And atomic probe tomography is actually a very well-known and used technology, but it's expensive, and there's only a few of them around. But what it does is it literally takes the sample apart atom by atom, about 1,000 atoms a second, and it figures out where its three-dimensional placement in that. So here's the idea. You create an electric field differential. You set it up so that you are evaporating the sample, and where it lands on the detector can be triangulated back to where it originated on the sample. And what do you get from that? You get a map of where things are. So this is the world's, at least public, first UAP alleged material studied at the atomic level and collected at the atomic level. So this is the Council Bluffs. It's a tiny, tiny thing. I mean, it's like literally 2 or 3 microns cubed, but there's millions of atoms in there. So, I mean, I knew that I wasn't going to find any structures, but this was an easy thing to start with. And then you look at the complexity of what's in there. So the first thing that, for instance, they were trying to explain this thing away as it was just industrial steel. Well, it's not industrial steel. Now we literally have things that industrial steels don't normally contain. But now we can go in and look closer. So here, for instance, this is 3D. Now we're inside the structure. I've taken away the iron, which is so prevalent as to be, would obscure everything. Now we can see the position of where everything is, right? Again, this is just a trial, but now we get to see potential structure. So I would say that if we're going to study any of these other materials that seem to have novel properties, this would be the way to do it. I had hoped to do the bismuth magnesium case before well, we tried it, but it fell apart in the instrument under the stress of the local forces. It was just too crumbly, unfortunately. There's a way to fix that, but we couldn't do it in time for this. Because that would have been cool. I think that would have got a bunch of us jumping up and down, but I'm going to do it anyway. It's coming. So you can look at all the individual atoms. You can't really see it so much. So those are the things that I showed you on the other page. Those are the individual atoms. Sorry, individual elements. There's some hints of potential differences here, but it's such early stages that I don't dare repeat. I don't dare say it until I repeat it. There's a lot more. I'm not an expert yet in APT, but I will be, in this. And by the way, this was, so the individual who's been helping me is Alex Bolton. You've seen him around. So he actually helped create all this analysis, and because we just got the data Friday, and while I was busy frantically dealing with Stanford administrative messes, he basically saved my bacon on that. But there's data, right? Now this is data. Material shows no sign of technology. The material is clearly the result of an industrial process, and it was incompletely mixed. Okay, so why? Again, that's the question you ask all the time when you see data. It's like, why? Why would you do it? What could have generated it? And why would you dump it in the middle of a field in a small farming town in Iowa? I don't know. I don't know the answers. Okay, so that's one case. There's another famous case, Ubatuba, 1950s. There's a primary witness, but we don't have it. Nobody ever had access to the primary witness, but a Brazilian journalist who received the evidence, and again, through the offices of Jacques, I was able to get access to some of this stuff. This is actually what I don't quite understand, is because, as you'll see from the result, it was claimed to be pure magnesium. What I was given was not magnesium. So, but we have two things called moisture A and moisture B, and that's Spanish for sample, I think somebody said, told me. And then this is the instrument that we.
I think about the progress that we've made and how long it's taken. He just said, and this is the case across the board, relatively speaking, that experiencers, anyone who's involved with this topic, they don't want to come forward. Decades and decades. Just think of the amount of people that have not spoken up. It's got to be just an incredible amount of people. I mean, this person saw this UFO drop molten metal, collected it, and will not speak to anyone about it. Gave the stuff to someone else, told them what happened, and disappeared. That's a shame. Things are changing finally.
Used highly accurate mass spectrometer. And just, this is the beginning of sort of how science is done. You don't want to measure different things on different days because you want the experiment to be done under the most similar conditions that you can. So those samples, two examples of each of those samples, along with a zoo of other things that Jacques happened to have, were put on this, and then we did the analysis. And I remember sitting there when they printed out the data, and I was like, I don't understand this. I mean, I hoped something like this would happen, but I never understood it. I still don't. So one of the samples, claimed samples, has pretty much exactly the natural thing. We had two shards of each. The other one was way off, way off. I mean, just no doubt. Um, okay, so why? 1950s, isotopes. If you mentioned isotopes to a 1950s crowd, they'd duck and cover, right? Because isotopes, and still humans use like one
Nuclear bombs.
of the most important things we do is we make nuclear bombs out of them. Of course, they're used in other for medical purposes and tracing. But we don't have any chemical or material reasons to use them. So, okay, so what's going on? So one had not. Why change the isotope ratios? Back then, it was extraordinarily expensive to do these kinds of separations. It's still expensive. I mean, my lab orders extremely small amounts of different isotopes from the periodic, from the lanthanide series, because we use them as tags in our biology experiments, because each of them is unique. So for the uninitiated, what are isotopes? Again, this is, thank you, ChatGPT, and it made some things up, of course. But, the idea here is, humans work with elements, but somebody is playing with isotopes. So why would you play with isotopes? Because they're supposed to be the same. That's what I was taught in chemistry. Well, it turns out that's wrong. Now people are starting to look at isotopes because you have an extra neutron in the element, and that changes the electronic configuration of the orbitals just slightly. And so in the right circumstances, having that difference would be sufficient to make a better catalyst. And so people, pharmaceutical companies and others, are starting to use this, starting to understand that, hey, there's something interesting here. Silicon, some of the isotopes of silicon make better qubit holders that last longer than others, than the other three. Okay, so
This is incredibly important if I'm understanding him correctly. He's essentially saying that these this was collected in 1957 and there is little to no use now for screwing with these isotopes, and certainly not back in 1957 out in the middle of a field. I mean, if anyone has any thoughts on what this molten metal, just fancifully, like, if it, let's say it did come from a UFO craft, what could it possibly be, and why would they be discarding it in a farm field? Please share if you have any clue or not, you know, if you have some kind of hypothesis. Thanks.
there it is. I mean, it's there. Plants use it. Actually, it's really fascinating. So there's something yet to be understood. Okay, so this was the first time that I had gone beyond just magnesium, looking at the Ubatuba material. And even though we looked at the magnesium, because that instrument that I just showed you can see down to the parts per million. We were looking at that level. When I looked at this, it was almost entirely pure silicon. Okay, well, what's the natural state of silicon? Sand,
Dan.
silicon oxide, quartz, things like that. It doesn't come prepackaged as 99.999395. You just don't get it. So why is somebody tossing that level of purity around? Because again, that would be expensive to make. So why would you do it? So again, we go.
Yeah, expensive now probably. This is 1957. Gosh, this stuff's insane. Our world is so much stranger, I believe, than we have any idea.
In and we're collecting this data. And by the way, I'm showing all of this because all of this will be going eventually on the web, and I want to do this with every material that I can get my hands on legally. Like I'll be like Lou and Chris sneaking something out the back. They weren't. I'm sorry. Chris is going to kill me. Um, good. And so again, look at the numbers there of the percent. There's lots of other things in there, but the vast majority is silicon. The reason why it shows as lower is because I broke it down into the silicon isotopes, and they're natural levels. So here again is the 3D, where we can go inside. And so one of the next things to do is to say, well, is there any sort of strange placement of the atom? So those are the three nucleotides. And is there a likelihood for one thing to be near another? And that's what we do, again, in immunology. We look for certain cell types that are more or less likely to associate with each other. And that tells you that, if that happened above statistical chance, then there's probably a reason for it. Things don't happen usually in biology by coincidence. The two samples are pretty much within statistical certainty to be similar to each other. So that's interesting. So even though they came from separate chains of custody, there's enough data here, at least, to say that whoever prepared this stuff either had identical preparation techniques or it came and it was broken and given into two chains of custody.
That is profound. I mean, amazing that those made it into his hands from 1957 in a field. Two, they split in two different directions and came back together in his hands, and he can prove with a reasonable amount of accuracy that the same entities made this. Wow. Wow.
Again, it's data. No sign of technology, but certainly signs of an industrial process. And that's important. So, I'm saying this thing about the silicon. If anybody can tell me why pure silicon should be thrown around a beach in, Brazil, I want to hear it, you know? So the material is clearly a result of an industrial process. It wasn't found randomly. Nobody found it on the side of a road. It was associated with an event. And that's important here. And because that coincidence, it doesn't prove that it's anything, but it makes it, to me, more interesting. Unusual levels of pure silicon with contaminants. So again, what would you do? So the event was somebody saw something supposedly with lights, and then it dropped something which exploded. Okay. Why? Right? Why? What's going on? I don't understand. Because on the one hand, we have these metals that drop. I have another sample of something from Australia. There's a couple of other events that actually are dropping molten objects. So there's a reason to offload something. Again, I'm speculating. There's a reason to offload something, but every time they do it, it ends up being slightly different. So does that tell you that there's many ways to achieve a similar goal? Right? So that's kind of sort of back engineering the thought process of why would you do something like this? So here's another case, very famous case, Socorro. Again, this is something from Jacques. On an Indian reservation, the police officer was Indian. He's driving along. He hears a noise. He sees something, a shiny object in a field. He observes little people outside of the object. The object takes off kind of with a burst of flame. And of course, when people tried to debunk it, they said he saw the star something or other. He's a trained observer. He's a policeman, right? So
Okay, I don't know if this is going to be all screwed up. The kids walked in. I didn't expect them for another 15, 20 minutes. I'm really sorry if that happened. Hopefully, this will record the last few minutes of the video. Please comment, guys. I want to have some conversation about this topic. And of course, like and subscribe. I'm trying to, I don't know, build maybe a channel for some discussion at least on some cool topics, not just UAPs. Oh boy.
Um, he didn't want to talk about it, so he wasn't seeking publicity. He just did it. So Jacques had a piece. He gave it to me. And again, we take an electron microscopy. Everything looks like it's from another planet under an electron microscope. Very simple. Aluminum, zinc, mostly, and some contaminants. But the aluminum and the zinc are in different places. So this is at a, a distance. So there it is. So there's the aluminum on the top. There's the zinc on the bottom, or vice versa. No, zinc's the green, yes, but it's differently distributed. It's the contaminants that are interesting. That's what I'm interested in, because they're kind of a signature. Are they uniformly distributed throughout the thing? Meaning, or are they somehow next to each other? So we looked at that. So now, if I look in the aluminum on the top, again, it's incredibly pure. It has like a single oxygen molecule amidst a million. I don't know who does that. And why would you do it? It's attached to a zinc thing underneath, which has some aluminum in it, but look at how it's non-uniformly distributed, right? There's like a cluster of it over here. Is that because they have a junky recipe? They didn't mix it right? It just is. But why? Don't know.
That is absolutely fascinating.
Again, this case, I mean, this is clear sign of engineering. I mean, the interface between those things is like exact, down to
Okay, I'm having a lot of errors. Very little happens from here on that is something that we can understand. Anyway, I'm gonna make some more videos on this topic. Um, I'd like to do some on the rift between these guys and Neil deGrasse Tyson. And if you guys have any ideas or want to toss some stuff out there about what these UAPs are dumping, please do so. Thank you for your time. Peace.